been looking at angles in a right triangle, yes?
Yes.
Okay. One of your angles in a right triangle is 90 degrees. How many degrees does that leave for the other two?
90.
90. So the other two have to add up to 90. So is it a true statement to say both of the other angles in a right triangle are acute?
Yeah.
And they add 90. Okay. So instead of looking at angles in a triangle today, let's go back to a graph and look at our angles from 0 to 360 degrees. I have drawn an angle in each quadrant. Kind of a random angle, like I don't want you to know the degree measurement. I don't even want to talk about the degree measurement of each angle. So let's first focus on an angle, any angle in quadrant 1. An angle in quadrant 1 is somewhere between 0 and 90 degrees, and we're going to call it an acute angle, yes? Okay. When I have an acute angle, like in a right triangle or right here, I can do sine, cosine, and tangent fractions on that angle. Because that's what you've been doing. You've been looking at an angle in a right triangle, you've been doing a sine and a cosine and a tangent fraction. Okay, so we have an acute angle. It's in quadrant 1. Let's kind of investigate it a little bit. So we're looking at the angle that goes to here. And notice I put a little point on here to kind of like stop it. What can I call this point? What's a very general term that I can call this point? Like a distance that I went this way to get there, and then a distance that I went this way to get there.
X, Y.
X and Y. I was hoping you'd say that. Now here's what's cool. When I look at this angle, and I look at this distance, which we'll call X, and this distance, which we'll call Y, I could kind of like draw those. Look what I've just created. I've just created a right triangle, and one of my angles in that right triangle is the angle that I had you looking at originally. Now I'm going to label this length right here. I'm going to call this length X. Would everybody agree that in my point, X comma Y, X is positive because we went that way? Okay, so I'm going to label it with positive X. What about Y? Is it positive? Okay, positive Y. And I'll call H my hypotenuse. Now, if I look at sides of a right triangle, I wouldn't say, well, this side is negative. You know, I wouldn't have a negative side. But you do know that if you go the other direction, your X value could be negative. But anyway, I've got this length, I've got this length, and I've got a hypotenuse length. Let's all agree to call our hypotenuse a positive length. Can we do that? This measurement here, it's going to be positive, okay? Always. So, watch what happens when I look at this angle and I look at making a sine fraction and a cosine fraction and a tangent fraction. Ready? Sine of this angle is going to be opposite, which is a positive y, over hypotenuse, which is a positive h. So I've got a positive over a positive, which reduces to a positive. Positive divided by a positive is a positive. Let's do cosine. Adjacent over hypotenuse, positive. A positive over a positive equals a positive. Tangent, opposite, positive, adjacent. Yes? Okay, nothing weird so far. Let's move into quadrant 2. This is where it gets weird. Now, I want you to look at the angle that starts here and that opens past this one, pass up 90 degrees, keep going, keep going, keep going, and stop here. I'm going to call this theta. would you all describe the angle that I'm calling theta?
Obtuse.
Obtuse. It's an obtuse angle. Is there any way that you can fit an obtuse angle inside a right triangle? No way. So would it kind of make sense to you that it'd be kind of difficult to do sine, cosine, and tangent on an angle that's obtuse because you can't fit the angle in a right triangle? Okay, we're going to do it. It's just going to be weird. We're going to do sine, cosine, and tangent on an obtuse angle, but it's going to be weird. So here's what I need you to do. This is our angle named theta. We're going to find sine, cosine, and tangent fractions for this angle that I'm calling theta. We're going to do it. It's just going to be weird. In order to do it, I want you to look at where the angle stopped and finish it on to the x-axis. See this angle right here? I'm going to put a capital R inside that angle. I'm going to call that my reference angle. So, we're going to be answering questions about theta, obtuse angle. We're going to be looking at R while we do it. We're going to be answering questions about theta, but our eyes are going to be on this angle while we do it. So, are you looking at that angle? You should be looking at that angle. All right. There's a point out here. I think I'm going to call it x and y again. There's an x distance, there's a y distance. Okay. My x distance now goes this way. Tell me something.
It's negative.
It's negative. My y distance goes this way. Tell me something. It's positive. And I've made a right triangle. Now, theta is not in my right triangle, but my reference angle is in my right triangle. Okay? So, again, we're answering questions about theta, but I want your eyes on R. Ready? Sine fraction. Opposite. Oh, I forgot to label it. Hypotenuse. Hold on. Okay, so sine fraction, your eyes are here. Positive, positive. Eyes here. Cosine fraction. Adjacent, hypotenuse. Negative over a positive equals a negative. Tangent fraction, opposite, adjacent. Okay? Moving on. I'm going to move into quadrant 3. Let's look at the angle that starts here around, we're going to pass 90, we're going to pass 180, we're going to stop here, and that's called theta. So theta is like anywhere from 181 degrees, could be anywhere in this quadrant, so 181 to like 269 degrees, somewhere in that range. No way theta can fit in a right triangle. So, we're going to look at the angle. Again, we're going to look at the side of our huge, I don't even know if I can call it obtuse, but the side of our huge angle with the x-axis. So now I'm going to put an R right there. Capital R. This is my reference angle. My reference angle always has one edge is my angle, the other edge is my x-axis. So important, x-axis. There's my reference angle. Here's my point. To get there, we're going to have a negative x again. And this time I'm going to have a negative y, right? Negative x, negative y to get down to this point right here. And hypotenuse, which you promised me you would always call it positive. Okay. We're going to be answering questions about this ginormous angle. To do it, your eyes are going to be right here. We're going to be looking at this one. Ready? Sine. Opposite. Hypotenuse. Cosine, look here. Adjacent, hypotenuse. Look here, tangent, opposite, adjacent. Kind of with me? Last quadrant. Biggest angle that we've made so far is going to be past 90, past 180, past 270. So we're talking like anywhere from 271 degrees to 359 degrees. That's theta. Too big. Okay. Let's look at a reference angle. I'm going to use the side of the angle along with the x-axis. I'm going to put R here for reference angle. I'm going to make my triangle. We already have positive x labeled. This would be a negative y. Answering questions about theta, eyes on reference angle. Here we go. Sine, opposite, hypotenuse. Cosine, eyes here. Adjacent, hypotenuse. Tangent, opposite, adjacent. Now, here I'm going to prove that it works. So you might have a calculator handy. Everybody has one out. Sarah Kate, pick an angle in quadrant 2. Anything, just make up something. 104 is an angle in quadrant 2, right? Are you in degree mode?
Yeah.
Okay. Would you do, Sarah Kate, would you do sine of 104, please? And tell us what you get.
0.97.
0.97, good. Cosine of 104, what do you get?
Negative 2.4. 0.24.
There you go, negative. And tangent of 104.
Negative 4.01.
Any angle, any angle. When you do sine, you're going to get a positive fraction. Now I'm calling it a fraction. You okay with me calling our answers a fraction even though she said a yucky decimal? I'm going to call those answers, those yucky decimals, I'm going to call them fractions. She got positive fraction, negative fraction, negative fraction. I could have her go on. I could have her pick an angle in quadrant 3. And when she did sine on her calculator, it would give her a negative answer. Cosine would give her a negative answer. Tangent of that angle would give her a positive answer. Guaranteed. You can do it all day long. It's never going to fail you unless you push the wrong button on your calculator. Okay, so that's how we're going to do sine, cosine, and tangent for angles that don't fit in a right triangle. Now, here's the thing. I need you to memorize all this. Maybe, I don't know. I don't know if you did this in Algebra 2 or not. I need you to memorize that in quadrant 1, all 3 fractions are positive. I need you to memorize that in quadrant 2, sine is positive and the other 2 are negative. I need you to memorize all those. But I've got a cool way for you to memorize those. Quadrant 1, which fractions are positive? All of them. Well, and we're going to focus on the positive. Has anybody ever said that to you? Have you ever been in a bad mood and you're like griping and complaining and your mom goes, let's focus on the positive. Let's focus on the positive. Which ones are positive in quadrant 2? Just sine. Quadrant 3, focus on the positive. Tangent. Quadrant 4, cosine. Notice that I started this whole thing in quadrant 1, and then we moved on to 2, and then we moved on to 3, and then we moved on to 4. That's the way you need to think about it. We're always going to start here and go in this direction. A, S, T, C. If you just look at the first letter of the ones that are positive, you get A, S, T, C. A, S, T, C. That's going to be how you memorize. It goes all positive, sine only positive, tangent only positive, cosine only positive. Now, some math teachers put a phrase to this so that this acronym is easily remembered. You can make up your own phrase if you want. Some math teachers say all students take calculus, but they're lying, because not all students take calculus. So I adapted it, but some people get their feelings hurt when I say it. I adapted it to awesome students take calculus. Can you think of anything? Somebody made up their own. I thought it had to do with rabbits, but I don't remember. They said something, something, tasty carrots. Anyway, all students take calculus, awesome students take calculus, whatever. That's what you need to memorize. Okay. This is what's going to be saved as page 3 of your notes. It's going to be the 3rd page of the PDF file. Stop here.